standing by, and welcome to the NASA CREW-10 Mission Overview News Conference. Your lines have been placed in a listen-only mode for today's presentation until the question and answer session. If at that time you would like to ask a question, please press star 1 on your telephone keypad. The call is being recorded. If you have any objections, you may disconnect at this time. Please continue to hold. Your conference will begin momentarily.
Good evening and welcome to this evening's CREW-10 Mission Overview Briefing. This follows the Flight Readiness Review, which just concluded ahead of the CREW-10 mission to the International Space Station. I'm Stephen Seisloff, the Commercial Crew Program Public Affairs Officer, and with me in the room and taking part in the teleconference today are Ken Bowersox, the Associate Administrator for Space Operations Mission Directorate at NASA Headquarters, Steve Stitch, Manager of NASA's Commercial Crew Program, Dana Weigel, Manager of NASA's International Space Station Program, Bill Gerstenmaier, Vice President of Build and Flight Reliability at SpaceX, and Junichi Sakai, Manager, International Space Station Program for the Japanese Aerospace Exploration Agency. And we will first go to Ken Bowersox for his remarks.
All right, thanks, Steve. We really appreciate all of you joining us today, where we'll talk a little bit about our late winter, early spring rotation with the CREW-10 launch and CREW-9 return that sets us up for Expedition 73 on ISS. We appreciate your interest in our people, our ops, our science, all the great work we're doing in low Earth orbit, and the way that low Earth orbit works to advance human spaceflight out to the Moon and Mars. It's amazing that we've been with Crew almost 25 years on the International Space Station, probably about 24 and a half now. We'll get to celebrate later this year. Dana's nodding her head over there. I love hearing about the work that's going on station. Today, or earlier this week, the Expedition 71 crew visited us at NASA headquarters. Mike Barrett, Tracy Dyson told us a lot about the work that they did when they were up there. They told us about the great science, about the dynamics amongst their crew, and I got tears in my eyes as I saw them sharing their pictures, looking out the windows, and their time together around the table, eating space food. Every month up there is a gift, and they sure enjoyed their time. Nothing that we do on ISS would be possible without our international and commercial partners that help us maintain the station for the health, safety, and useful work of our astronauts and cosmonauts. We have a wonderful private-public partnership with SpaceX. They've been very flexible with us over the last couple of years, coming up with new ways to handle almost anything that comes our way on the International Space Station, and I can't tell you how much we appreciate that partnership. Same thing goes with our Japanese and Russian partners. They're always there to help us if we need it, and it's great to see the flags of Japan, Russia, and the United States on the crew that's getting ready to launch here. Anne McLean, Nicole Ayers, Takuya Anishi, and Kirill Peskov. You'll get a chance to talk with them after you talk with us today, and I know they'll be happy to share what they're doing on their flight. So we had a flight readiness review today. The full team polled go, pending closure of some open work. Steve will give you a lot more detail about the open work. We've got an issue with coding on the Dragon thrusters and some late-breaking issues that we're dealing with because of the rapid pace of operations with our partner SpaceX. It's exciting for NASA to be able to deal with these late-breaking issues and try to keep up with SpaceX. It's hard for us. We're not quite as agile as they are, but we're working well together, and it's really helpful and healthy, I think, for our NASA team. I'll also tell you that we're not going to launch before we're ready. We're always analyzing the data and making sure that the rocket is ready to go before we let the SpaceX team hit the button with our crew on board. And with that, I'd like to just pass the mic to Steve.
Yeah, thanks, Ken, and thanks to all of you for being here this evening. Really appreciate your interest in the Commercial Crew Program and human spaceflight. It's my honor to be here representing our Commercial Crew team. As Ken said, we had a good flight readiness review today. We really, as he said, everybody pulled go to proceed. We have two issues which I'll talk about in a little detail. I'll have Gerstenmaier talk about one of them, but on the Draco thrusters, we have some coding that we've seen some degradation on higher flight thrusters, and we have to work through that. And then on the recent Starlink launch, there was an engine 8 combustion event after landing that we want to make sure we understand relative to how the vehicle performs during the ascent phase. This is a huge mission for us on CREW-10. They're all big, but it started all the way back to CREW-9 when we launched that mission with 2 empty seats, and we had those seats reserved for Butch and Sunny, which we're planning to bring home on CREW-9. We also flew up, as you might remember, a suit for Butch on CREW-9, and then also some seat liners that we have in place for Butch and Sunny to come back. Butch and Sunny have done a great job. Dana can talk more about all they've done during the expedition, but a lot of contingency work on station, EVAs that Butch and Sunny did. They have done on-orbit training in the Dragon spacecraft and just done a phenomenal job, and so we're excited to bring them back. Our launch target for CREW-10 is March 12th at 7:48 p.m. We've moved back to Launch Pad 39A for this flight. You might remember last flight we flew off of 40 because we had to delay that flight a little bit. For our launch on March 12th, docking would be, it's a very short phasing, so it would be the next day at about 6 a.m. Eastern time. So it's a real short phasing opportunity. And we have backup opportunities for a launch on March the 13th at 7:25 p.m. Eastern, and also on Friday, March 14th at 7:04 Eastern. And so those are backup opportunities. In terms of hardware processing, Dragon is in the hangar up at 39A. It has been mated to the Falcon 9, and it's on the transporter erector. The next big event, of course, we're flying Dragon Endurance on this flight, which will be its fourth flight, and a second flight booster. We'll roll out to the launch pad tomorrow night is the plan, and then we'll get into our normal static fire and dry dress operations. Those will be on Sunday night, and then we'll get into the LRR. It's been an unusual flow in many respects. One of the things that we did on this flow is we swapped Dragon capsules late. We swapped over to the Dragon Endurance vehicle. Instead of flying a new capsule, that new capsule had a little bit of problems in production. And so when we looked at where that vehicle would be, we accelerated the launch from what would have been a late March timeframe into the March 12th timeframe with a Dragon vehicle Endurance, which had flown. Now it'll be its fourth flight. When we did that, we had to look at the thrusters very carefully on this vehicle. They were originally slated to fly on a private astronaut mission, and these thrusters had higher life than we had flown before for commercial crew, and also had more pulses on them. And so when we looked at the thrusters, one of the thrusters in particular had some coating degradation. The thrusters have a coating on the outside and inside that protects the base material from being oxidized during the firing of the thrusters from that heat. So we removed what we call quadrant 3. We removed that whole cluster and had one of the thrusters off there. And then that thruster with the coating degradation, we've had to look at that a lot more carefully. There's 3 other thrusters on this vehicle that have a little bit of coating degradation. So we're in the process of actually hot firing an engine at McGregor with SpaceX to put it through not only a normal mission cycle, but a total of 4 mission cycles, and then plus a couple of extra contingency cycles. And so that is one of the items that's open coming out of the flight readiness review. That's an exception. the coating loss on that particular Draco thruster. We have some new items also for CREW-10. For the first time for crewed missions, we are moving in commercial crew over to the Pacific Coast. Now, we're looking at flying that on a cargo mission beforehand, but it's a huge amount of work to move over to the Pacific Coast, and we're doing this so that we can deorbit with the trunk and put the trunk in a very tight window in the Pacific Ocean. We had to establish new landing sites on the West Coast, do staging areas, look at the medical facilities, obtain support from other government agencies, including the FAA, and we had to also look at the engines, the four forward bulkhead Draco engines that fire for a longer amount of time. Normally they fire for about 17 minutes. They fire for about 24 minutes. This capability is in the flight software in Dragon, and we'll finish up the cert on that before we actually use that capability for landing. But that allows us to land at either the current landing sites or the Pacific landing. And so to do so, we have a single recovery posture at both the West Coast and East Coast. We'll have one ship on the Gulf sites for CREW-9 return, and then one on the Pacific Coast off the coast of Los Angeles for the Pacific recovery. CREW-9 will land, will be our last flight planned to land back on the East Coast, and we plan to use the Gulf sites for those. We've added a new landing site called Tortuga for that, and we're really looking forward to using that site if we have to, and we added that site in order to mitigate potential weather delays. We also are going to fly what we call an energy modulator upgrade on the parachute system. So the energy modulator, think of it as like a spring device that absorbs the impact when the drogue pulls out the main parachutes. We're going to fly that upgrade for the first time on our crewed mission. We have a little bit more work to do coming out of the FR to close that up. We did extensive testing at the Langley gantry facility on that new energy modulator, and we also flew it on a cargo flight. Dana helped us fly it on CRS-31. On the Falcon 9 side, we have I'll let Gersh talk a little bit about Starlink, but we have a few things that we're working on that vehicle as well. We have had on the TVCs, thrust vector controls on the engines. We've seen some FOD. SpaceX identified this well before our flight. So we swapped engine actuators on Engine 1, Engine 5, and Engine 9. We had to work through those swapped actuators and get flight rationale for flying those. So we did that, and we also we have new actuators on the MVAC engine on the second stage to handle the servo valve FOD issue. We also worked through some quality inspection misses on some hardware for Falcon 9. SpaceX did a great job of flagging this potential issue and did a scrub of all their quality inspectors across all their Falcon 9 vehicles, all their flights. We went through that with our vehicle and our hardware, and we were able to conclude that the hardware is acceptable to go fly. So overall, we're in pretty good shape. We have a couple of issues that we need to go work through. Every FRR is a bit like this, where we have a couple late-breaking issues that we've got to work through. We'll go do a dry dress of the Dragon and static fire, get the crew in Dragon, get it checked out, and then also do a static fire, which will help us understand our engine performance, and then we'll go fly when we're ready. And with that, I'll hand it over to Dana.
Thanks, Steve. And thank you all for joining us today and for your interest in both CREW-10 and in the ISS mission. With CREW-10's planned launch on March 12th, that'll put docking to the Node 2 forward port on March 13th around 10 a.m. Eastern Time. After CREW-10 arrives, they'll do 2 full days of handover with CREW-9. That'll include safety-related items and also overall familiarization on board space station. And of course, after that, CREW-9 will undock and then return home. So for a March 12th launch, CREW-9 undock will be on March 16th. Of course, weather always has to cooperate for that, so we'll take our time there if weather is not favorable. Looking at the activities surrounding CREW-10, there are a number of other mission events in our station plan. Just today, Butch rang a ceremonial bell on board as Sunny handed over the ISS command to cosmonaut Alexei Ovchinin. Last week, the Progress 91 launched from Baikonur, carrying thousands of pounds of cargo on board. That progress docked to the aft port of the service module, Zvezda, on March 1st. At the end of March, we'll be completing our Northrop Grumman 21 mission, and then the crew will robotically unberth that vehicle from station's Nader port on Node 1, and we'll release it. In April, there's a Soyuz crew exchange, starting with the launch of the 73 Soyuz on April 8th from Baikonur, Kazakhstan. That Soyuz vehicle will be carrying NASA astronaut Johnny Kim. The Soyuz crew will do an exchange, and then Don Pettit will be returning on the 72S Soyuz. Then in mid-April, we'll launch the SpaceX 32 cargo mission carrying critical resupply and research. I do want to briefly talk about our upcoming Northrop Grumman 22 mission, which is planned for June of this year. The station program and Northrop Grumman are assessing potential mission impacts to that NG-22 mission. Following the recent shipment of the Cygnus pressurized cargo module, that's basically the pressurized portion of that spacecraft, the part that opens up to space station. NG noticed that the shipping container that's around that pressurized cargo module had sustained some damage. Our teams are working with NG to follow along with what they learn as they inspect the module, and I expect that we'll have to have some follow-on discussions and assessments to determine if there is spacecraft damage or any impacts to the overall mission schedule for flying that flight. It's a critical resupply mission for us, so as a precautionary measure, we've changed the upcoming SpaceX 32 cargo manifest. We've removed some of the research that we had planned to fly on that flight so that we could add more food, consumables, and additional vehicle spares that were originally manifested on NG-22. We also, as I mentioned earlier, slightly shortened the crew's handover. They typically do a 5-day handover. We shortened that for 2 days just to conserve consumables on board. And what that really does for us is it just opens up more undock opportunities, so we have a chance to find a good weather opportunity for undock to minimize how long we have additional crew on board. Space station resupply and research is pretty complex. It relies on hundreds of vendors across the globe. I am very grateful for the work they do and for their flexibility in response to our dynamic mission needs. We're looking forward to having CREW-10 on board. When they get there, they'll be set to support a number of scientific investigations and the exciting missions that will take place during their expedition. And with that, I will pass it to Bill Gerstenmaier with SpaceX.
All right, thanks, Dana. Human spaceflight's core to SpaceX's ultimate mission, and flying crews safely is always our top priority. Spaceflight is really hard, and we're learning every day. The more we fly, the more we learn. Crew readiness reviews give us the time to step back for a moment and kind of double check our logic for flight rationale and make sure we're really ready to go fly. I'll talk to you about 2 topics that we discussed during the flight readiness review today. Last week on Starlink G12-20, after successful landing, an off-nominal fire broke out in the aft end of the rocket. It damaged one of the landing legs, which resulted in the rocket tipping over. While it's disappointing to lose a rocket after a successful mission, the team will use this data to make sure that every Falcon is more reliable on ascent and landing for this mission and for every other mission going forward. We got a chance to see how the hardware really performs in an extremely off-nominal environment, and that's a pretty rare instance to get a chance to see that. The engine was fully contained in the compartment like it was designed to be. The fire was pretty extensive, did a lot of damage, but the damage is what we've expected, what is accounted for in all our procedures and processes. We're reviewing that data with NASA. We also don't see this as a big concern for the primary mission. It turns out there was a fuel leak during ascent that showed up about 85 seconds into ascent. It essentially sprayed some rocket propellant, essentially kerosene, onto a hot component of the engine. It vaporized and created a flammable environment. but on the way up, there was no oxygen to interact with the fuel, so there was no problem at all during ascent, and it was perfectly fine. The mission was accomplished. And coming back after we landed, about 45 seconds after we landed, enough oxygen came into the compartment where it interacted with the fuel and a hot portion of the engine, which was known to be hot. And then we had a fire, and it blew out the barrel panel on the side of the rocket, just like it was designed to. The fire was all contained to the engine compartment. And even if we would have had a problem during ascent, this shows that the fire and the damage would be contained to just a single engine out, which still allows us to accomplish the entire mission. So we developed a risk. We put all the rationale through that. We're double checking. We're trying to see if we can understand what occurred that actually caused the fuel leak. It's pretty difficult to determine what was cause and what was effect from the fire. The fire was pretty extensive. It melted a lot of aluminum components, so it's difficult to see. But we're going through the forensics. We've got the engine out. It's available at the Cape. We'll continue to keep looking. We'll continue to keep briefing NASA, and we'll be ready as we move forward. So again, I think we're in good shape with that. We have a good understanding, and we'll improve our knowledge, and ultimately we'll be safer because of what occurred on this flight. A month earlier, on a different launch, G12-9, on the 8th of February, a second stage developed a small oxygen leak. This froze a thrust vector control line and prevented proper attitude control. The control was still good enough that the Starlink satellites were deployed properly, but when the deorbit burn came around, the rocket couldn't get in the right configuration for the deorbit burn. So as the software says, it skipped the deorbit burn, it passivated the stage, and this stage ultimately re-entered, I think, last week over Poland. And again, crew flights are really too short for this freezing to occur, so it's not really a concern to us. But we also have put some extra checks in place, and we've tightened our abort limits such that we have any kind of oxygen leak on the second stage, we'll detect that prior to pre-launch. We'll also get a chance to check that with NASA during the static fire and make sure that that's all okay. So again, I think this is an example where we're flying other missions for other reasons. We're discovering problems on the rocket, but it's ultimately making us safer. So this manifest rate that we're flying a variety of payloads we're flying, the equipment we're flying, is really giving us information that we would not be able to obtain from any test stand, any amount of testing on the ground. So we're actually going to be more reliable by being smart and learning from these events and sharing our data with NASA. So again, we spent extra time and we're giving extra care to CREW-10 booster. We're working closely with NASA to work out any questions well in advance of launch, and always we'll only launch when Dragon and Falcon are really ready to go fly. And with that, I'll turn it over to Sakai Junichi from JAXA.
Thanks, Bill. I'm Sakai Junichi, the ISS Program Manager of JAXA. First of all, on behalf of JAXA, I would like to sincerely express my appreciation to NASA, SpaceX, and all the colleagues working for the CREW-10 launch preparation and continuous ISS operations. I'm honored to be here today to announce the flight of our Japanese astronauts Onishi Takuya. As reported earlier, we have decided to go for the CREW-10 launch and the CREW-9 return with pending closure the open items. JAXA, including the astronaut Onishi Takuya, are ready for the launch. This will be the Takuya's second long-term mission. After his first mission in 2016, he understood the importance of cooperation with the ground staff and had a strong desire to deepen his knowledge of the ground operations. So he became a flight director. Since then, he has been supported a lot of experiments in orbit from the ground, utilizing his perspective as an astronaut, and worked as a flight director until January 6th of this year. This time, he will complete a long-term stay utilizing his new perspective from the ground control team. I believe he will greatly enhance the formation of teamwork with the ground team and bring back a lot of accomplishments. For this long-term stay on the ISS, Takuya will be appointed as the third Japanese ISS commander following Koichi and Aki. I expected that in orbit, he will bring out the best in the ISS team members and build the best team for the mission success. I'm looking forward to this coming launch, and we will continue for final preparations. Thank you.
Thank you, everyone. We're going to move to the media questions now. For media participants, it's star 1 to get into the question queue. And if your question is asked and you want to withdraw, star 2 is the way to do that. We will start with Marcia Dunn at the Associated Press. Go ahead, Marcia.
Yes, hi, thank you. 2 questions. I'm wondering why the Dragon capsules weren't swapped sooner for CREW-10, which would have allowed Butch and Sunny to come home sooner. And did Butch and Sunny's unexpectedly long stay add to the consumable shortage? How tight is the food situation and other supplies? Thanks.
I'll address the capsule swap, and then we'll let Dana talk about the food situation. This capsule was slated for a different mission at one point, and we're always looking and refining the manifest. So, we looked at when we had a couple of. If you remember, our launch date originally was mid-February of this year on the new capsule, and then we started looking at that capsule as it had a couple of problems in prop checkouts, which is very typical of when you're building a new capsule, a little bit of problems with the ecosystem. We started looking at that schedule, and at that time, early this year, in late January, that's when we finally decided, hey, we'll move to Capsule 210 on its 4th flight. We knew that the thrusters on this vehicle would be a little bit problematic for us to clear, and so we were a little bit hesitant to swap to this vehicle. But we have learned a lot about the thruster capability in this swap, and then our team has done a phenomenal job. I can't compliment our team enough. The typical certification for a vehicle takes roughly 4 months or so to get through all the Dragon work. We look at any nonconformances, any risk on the vehicle, all the hardware. Our NASA team has been able to do that in about twice the time, which is really incredible. Do appreciate the flexibility that SpaceX has provided for us with having a capsule almost ready to go for us, and so we moved ahead with that. And I'll let Dana talk about the food.
Yeah, the big challenge for us is when our flights start to shift around. We look at our manifest across a number of different flights, and we usually fly a combination of research, food, water, vehicle spares. And our original plan had a Northrop Grumman flight, the NG-22 mission, flying in February. I think it might have even been slightly earlier at one point, but for a while it was in February, and then they ran into an avionics issue, and they had to do some rework on the vehicle and push that out to June. And so the real challenge was in just the large movement of our cargo missions. And so had I known that earlier, we could have added more to our fall flight. But, we tend to try to, again, balance the consumables across them. So that's really why I changed the plan for upcoming 32 is if we're going to have another shift of our cargo missions, I've got to adjust and accommodate more food.
Thank you. And next we're going to Miles Doran at CBS News. Go ahead, Miles.
Hi, question for Steve Stitch about the late capsule swap for this mission. From a safety and mission assurance standpoint, was NASA able to complete all of the product assurance actions or inspections that would normally be done during the flow of a Dragon flying a NASA mission, since it was initially being prepared for a private mission? Were there any processes or activities that the government was not able to witness because of the late change in spacecraft? And on the Draco thrusters, where you've seen the degradation, where are they on the vehicle? Thanks.
Yeah, I'll talk about the product assurance actions first. We typically witness certain activities. One in particular that we witness is the installation of the thermal protection system on the heat shield. That was one activity on this capsule that we did not physically witness with our NASA engineers in person. What we did do is we went back and looked at all the records for that work, all the documentation that SpaceX provided, We looked at they do a bond pool for the installation of every component of the TPS on that composite part of the structure. So we went and looked at that. We looked at any repairs that they did and went through all that work. And we were able to determine that it was safe to go fly based on, we'd already looked at more than 10 heat shields, installations of all the TPS over the life of our program. And so we were able to use that experience plus knowing what SpaceX had done, looking at the record reviews, and conclude that was okay to go fly. We did go through and there was a couple of other inspections that we typically do. We look at on the composite overwrap pressure vessels. This is a composite tank for the fuel tanks. We typically do an inspection of some of those, and again, we had to look at the closeout photos that SpaceX took and look at a record review. So we went methodically through every single PAA that we would have done, and we dispositioned each one in prep for flight. The thrusters that we're talking about are the Draco thrusters on what's called the service section. So there's kind of an aft firing thruster, a forward thruster, and a roll thruster. And what we've seen is there's a coating on the outside of the thruster that is used to prevent, again, oxygen from getting to the base material. And that coating we've seen some cracking on some of the higher life thrusters. So we removed one thruster that was deemed not acceptable to fly. And then there's 3 others that have a little bit of coating degradation. What we've done is we've taken a companion thruster that has the same exact life. In other words, it flew on the 3 previous missions exactly. It went through the saltwater exposure, and we're taking that thruster, hot firing it at McGregor, putting it through essentially 4 times the number of pulses we would see on our flight. Once we get through that, plus we cut up a thruster as well to look at the coating loss and how far that coating, any cracks in that coating could penetrate down into the base material. We did some of that work at SpaceX at Hawthorne and then also at the Glenn Research Center. And so we're in the process of pulling all that data together to examine it and ensure that we're safe to go fly with these Dracos.
Thank you. Next, we're going to Jonathan Seary at Fox News. Go ahead, Jonathan.
Thank you so much for doing this. My question's for Steve. Following up on Marcia's question, did President Trump's call for Elon Musk to expedite Butch and Sonny's return factor at all into the Dragon swap out, or was it always based on other factors that would have made it happen anyway?
Yeah, that's a great question. So, we really have a pretty busy manifest coming up here in the spring. The first part of the manifest now is this CREW-10 mission. And so if you just kind of look at what's happening at Space Station, we've got CREW-10 followed by a Soyuz handover in April. And then after that, as Dana talked about, there's a critical cargo resupply mission that needs to fly in that late April timeframe. And so when we laid out all those things, we really wanted to get this mission flown before the Soyuz and before we had this critical resupply mission. So in doing so, we looked at the March timeframe. So when could we go fly in March? Well, it turned out as we looked at this capsule readiness, the earliest this mission could be flown was right after the Intuitive Machines mission had freed up the launch pad at 39A. And so when we laid all that out, we ended up with March the 12th. And so it really was driven by a lot of other factors. And we were looking at this before some of those statements were made by the President and Mr. Musk.
Well, and this is Ken. I can verify that Steve had been talking about how we might need to juggle the flights and switch capsules, a good month before there was any discussion outside of NASA. But the president's interest sure added energy to the conversation, and it's great to have a president who's interested in what we're doing.
Thank you both. Going to Micah Maidenberg at the Wall Street Journal. Go ahead, Micah.
Hey, good evening. A question for both Ken and Bill. Just looking back to last year, could you both talk about any options that SpaceX may have come up with to bring Wilmore and Williams back sooner were those offered to NASA? What were they, and any sense of the cost? Thanks.
So, the SpaceX folks helped us with a lot of options for how we would bring Butch and Sunny home on Dragon in a contingency. And they've been so helpful this last year coming up with those options for how we might put crews in the mid-deck of the Dragon. When it comes to adding on missions or bringing a capsule home early, those were always options, but we ruled them out pretty quickly just based on how much money we've got in our budget and the importance of keeping crews on the International Space Station. They're an important part of maintaining the station, so we like to keep our crews up there.
And we're always ready to support NASA in any way we can. When this kind of came up, NASA said, what could we do to help? And then we worked with NASA collectively to come up with the idea of just flying 2 crew up on Crew-9, having the seats available for Sunny and Butch to come home, and that's what NASA wanted, and that fit their plans. That allowed them to use Sunny and Butch in a very productive manner, make them part of the crew on board station, and make really a seamless integration and keep the science going on station and keep pushing research. So it was our pleasure to figure out a creative way to support NASA and to keep the mission of space station of pushing science and commercializing space forefront for this nation to keep us a leader in space.
Thank you both. Going now to Kenneth Chang at the New York Times. Go ahead, Kenneth.
Yeah, hi, thank you. I guess I'll follow up with Bill. So Mr. Musk said that SpaceX had a specific proposal for bringing Sunny and Butch back early, and NASA turned it down for political reasons. What exactly was that proposal, and when was it made? I guess for Ken and Steve, was anyone outside NASA or the White House involved in the decision not to bring Sunny and Butch back sooner? Thank you.
So I think I think there may have been some conversations that I wasn't part of. I know when we made the technical decisions about Starliner and what we were going to do with Butch and Sunny, our leadership at NASA was trying to make sure that we considered everything just at a technical level, and that's what we did. Steve, anything you want to add?
Yeah, I would say, we looked at a wide range of options and worked hand in hand with SpaceX to look at what was the best thing to do overall when we concluded that Butch and Sunny should not return in Starliner. And it's very complicated in terms of having the right size seat for the crew members. And so when we started looking at what flight opportunities we had, getting the seat right in the seat and the liner in the seat is important with the suit for making sure that the crew's safe during entry and that when they make contact with the water under the parachutes that they're safe. So when we laid all that out, the best option was really the one that we're embarking upon now, and we did on Crew-9, flying the 2 empty seats, flying a suit for Butch up on Crew-9, and also making sure that the seats were right for Butch's anthropometrics and Sunny's to return them safely. And so it really was driven by that in conjunction with Butch and Sunny being very experienced crew members, and Dana might want to add them to the increment and then make them productive members of the increment crew, which they've been ever since they joined the Crew-9 right after the Starliner departure.
Yeah, I will just add that pre-flight, knowing that we were going into a test flight with Starliner, and you test because you want to make sure you fully check out a vehicle and you don't know what you're going to find or learn. That's why you fly a test. We actually had Butch and Sunny go through all of the long-duration space station training well in advance. And when they were assigned, we got spacesuit parts for them, and I actually put them on board many months before they launched. So we had hip pocket contingency plans that would allow them to be long-duration crew members well before they launched. And as Steve said, when we looked at the situation at the time, we had a Crew-9 launch in front of us. It made sense to take the opportunity to bring Crew-9 up with just 2 seats and have Butch and Sunny fill in and do the rest of the long-duration mission.
Thank you, folks. Going next to Jeff Faust at Space News. Go ahead, Jeff.
Hey, good evening. Question probably for Ken. We heard from the Crew-9 astronauts earlier this week about how busy they are on the station doing science, and the station should be kept going to 2030. Elon Musk has talked about his desire to retire the station as soon as 2027 to focus more on going to Mars. Since Musk's comments, has NASA started or been asked to start any sort of studies about the feasibility of accelerating the end of the ISS from 2030?
So right now we're acting purely on policy guidance that we have in place, and that has us flying on ISS through 2030. That's something that we've negotiated with all our international partners. Of course, our Russian partners still haven't been able to get official approval to extend past 2028. So we're dealing with a little bit of uncertainty officially between 28 and 2030. The key things we have to have before we bring the space station back to Earth are, one, the U.S. deorbit vehicle needs to be on board, and two, we'd like to have another station in place so we can continue our work in low Earth orbit. The work we do in low Earth orbit contributes greatly to our ability to expand humanity from Earth to the Moon and Mars. It's always been an important factor on the International Space Station. We've learned a lot, and there's still some work that we'd like to do in low Earth orbit. So I think we'll find that humanity keeps working in low Earth orbit for a long time to come, and I think it will help us accelerate our ability to go to Mars.
Thank you. And next we're going to Eric Berger at Ars Technica. Go ahead, Eric.
Hi, thanks very much. And just to follow up on Micah and Ken's questions, and I'm sorry to sort of harp on the Crew-9 stuff, but it's the first time we've really had a chance to talk to anyone for a while about this. Anyway, just to follow up, it sounds like the decision made last summer in late July or early August on how to bring Butch and Sonny back, the decision not to do a dedicated mission but to put them on Crew-9 was made at the program level, the ISS and commercial crew program level. Is that correct? It was not made at headquarters or above?
I mean, Dana and I worked to come up with a decision that worked for the commercial crew program and space station, and then Ken, we had the flight readiness review process with you and the administrator of NASA listened in as well. So we had a recommendation to the agency and was following the process that we typically use. So.
And that's typically the way our decisions work, right? The programs work what makes the most sense for them programmatically, technically. We'll weigh in at the headquarters level, and in this case, we thought the plan that we came up with made a lot of sense, and that especially for Butch and Sonny, we know they're experienced astronauts. They're great in space. We knew they'd be great additions to the crew, and we knew that for most astronauts, spending extra time on orbit is really a gift, and we thought they'd probably enjoy their time there. So we thought it was a good way to go, and for a lot of reasons.
Thank you. Next, we're going to Joey Roulette at Reuters. Go ahead, Joey.
Hey, thanks. Quick question for Ken. You said earlier that SpaceX is moving at a rapid pace and that it's sometimes hard for NASA to keep up with them. And I was just wondering if you could go into a little bit about what you meant there and what's driving that rapid pace. And overall, for Ken or Steve or anyone else who wants to answer, does swapping these two capsules this late before Crew-10 increase just generally the safety risk to astronauts? And do you think that's worth, the benefit of bringing the Butch and Sonny home earlier? Thanks.
So let's talk about SpaceX's rapid pace. They're launching more than 100 times a year, and they're reusing vehicles. It's amazing. 10 years ago, I heard things from people like, why would we ever reuse a vehicle with a crew on it? why wouldn't we just fly brand new vehicles every time we fly a crew? Let me tell you how things have changed. We've all gotten to the point where we'll say, oh, brand new vehicle, I'm a little bit nervous. Were they able to do everything right in production? How about giving us one of those flight-proven vehicles, right? NASA's changed that way. With the number of flights that SpaceX accomplishes in a year, there is a ton of data on all those flights. We love data. We love to process it at NASA, and that's created a lot of extra work for us to go through all that data. But we've also come up with creative ways to deal with the data, and SpaceX has helped us with that. And so you always have this gift of the extra data, but then you have to figure out how you deal with it in a mature way, especially when it's coming in rapidly. And it's been wonderful to watch our team developing that ability. Steve?
Yeah, I would say the Falcon 9 flights that SpaceX flies, they fly a wide range of missions, wide range of customers on their flights, and then what they can do is cut in changes on those flights ahead of a crew flight, and so we can watch a change on those flights, see how it performs, try to understand what the risk is of that change. And we have what I would call good fleet surveillance. We sit down every week. There is a review of the previous period of times Falcon 9 flights. We sit in on those reviews. And then there's learning that benefits us. For example, as Gerstenmaier talked about the Starlink flight with the Engine 8 anomaly post-landing, we have an opportunity to step back and think about our flight and think about the maintenance we did on our vehicle, all the areas that we inspected. We'll go static fire the vehicle and look extra careful to see if there's any area where we could potentially have a fuel leak. So it kind of points us to areas that we could go look at and examine and focus on for our crewed flights. In terms of extra risk for flying Capsule 210 Endurance, you know, that capsule we're very familiar with. It flew on Crew 3, Crew 5, and Crew 7. So it's flown pretty recently. We have gone through, had an opportunity to go through all the various what I would call issue tickets or non-conformances on the vehicle. We've went through all those. Again, I talked about the product assurance activities that we went through, and so we are going through and flying at a normal risk level on that capsule, except for the Dracos. Again, we have to go work through that. So that's the one area. There was some learning relative to the Draco coating. SpaceX had been flying for crew flights. We only had allowed 2 flights of the Draco thruster, so only a second flight on the Draco. Now we're going to fly 3 thrusters for the 4th time on this vehicle. That's the only area where we needed to look a little more deeply and make sure that it was safe to go fly.
And I would just add, as I said in my opening remarks, it's, you know, the flight rate can be seen as a problem, but I actually see it as a tremendous advantage, and it's actually letting us get more experience flying. So instead of, you know, we talk about test like you fly, we fly like we fly. So we're actually flying, we're actually seeing the hardware operate, we're getting real flight experience. We can provide that data to NASA. NASA can see that data, and we actually end up with a much more reliable product going forward. In terms of the Dragon capsule, we had that capsule fully ready to go fly one of our commercial flights. It's neat to see NASA come in and then kind of double check our work and go over some things and ask us to go check some things. We're in the middle of doing the hot fire testing for the Draco, as Steve talked about. We're about halfway through that testing. It'll probably be completed tonight. We'll actually do a proof testing, and that data will back up probably another qual engine that we did about 5 years ago that will show the same data. But again, we'll get a chance to double check our work, show what we're doing, and the oversight that NASA provides helps make both of us stronger. It's a double check for us. It's a sampling of our systems to make sure we're not shortchanging something, and we all benefit by this partnership of us working together, and we're going to be absolutely ready to fly CREW-10, and if we're not, we'll delay to what we need to go fly.
Hey, thanks for bringing that up, Bill. I like to mention our private astronaut missions and how they bring benefit to NASA. We learn about how the commercial market is developing in low Earth orbit. But we also have extra vehicles in the flow, and this is a great example of by having an extra vehicle in the flow, getting ready for the fourth private astronaut mission, we were able to take advantage of it and do a switch with the 213 capsule that we had been planning to use. I love having that flexibility, and I think it's helpful for Steve too, and Dana.
Thank you. Next, we have Will Robinson-Smith at Spaceflight Now. Go ahead, Will.
Yes, hi. Thanks for taking the time to talk with us this evening. Question for Gers. We talked a lot about bringing the capsule forward from the private mission to be used on CREW-10, but can you give us an update on what's the status of the fifth and newest Dragon capsule that originally was going to be used for CREW-10 and how soon it may be ready to support a mission? And briefly for Stitch, if I may, can you provide an update on where things stand with the next flight of Starliner, if it's going to happen later this year with Crew, just what's the latest with that side of Commercial Crew? Thanks.
Yeah, as the final problem we had with the new capsule was we had a battery problem, so we ended up pulling the battery out. We understand now exactly the failure of the slice that occurred on that battery. We're ready to go reinstall the battery. It turns out the batteries are not easy to get out. It took a lot of capsule disassembly to get the battery out. We're ready to go put it back in. Our focus has now been, we kind of shifted all our workforce to get ready for CREW-10 as soon as we could. We'll turn that back around and we'll get ready to get the new capsule ready to go fly at the right time to go fly. We have potentially another private mission, maybe sometime this spring, that we're working on with another capsule. So as Ken said, we have a variety of capsules that are in various states of readiness to go fly.
And let's see, to address the Starliner question, we're making good progress on closing out the in-flight anomalies and the in-flight observations from that. We're approximately 70% closed on all those items from that flight. In parallel, we continue to work through the prop system issues, that being the helium leaks that we saw, and then also the thruster degradation that we saw on that mission. We've got some candidates for the helium seal replacement that are in test already. We continue to do modeling of the thermal performance of the doghouses. We have a plan to actually take a doghouse and test that out at White Sands later this year. We'll test the one we flew first in a vacuum chamber that we can actually hot fire the engines on that. And then we have some modifications we're going to go fly in terms of some thermal blankets and some areas that keep the OMAC plume from coming back into the doghouse. We'll fly that configuration. We'll collect the data from those two different tests, and then we'll use that to anchor our models. Once we get through those campaigns, we'll know a little bit better what we will do with the flight in terms of when we will go fly the next flight for Boeing. We'll continue to work through certification toward the end of this year and try to, whatever we do, the Starliner vehicle will be crew capable. When we look at the manifest for this year, it's pretty busy in the fall time frame. So Dana's got a pretty critical mission she'll fly on the SpaceX 33 cargo mission, which will be used to reboost station. So we've got to go figure out manifest-wise, where does the Starliner fit? Does it fit best toward the end of this calendar year, the first flight back after CFT, or early next year?
Thank you. And next we're going to Marina Koren. Go ahead, Marina.
Hi, thanks. This question is for Bill. Bill, you work at SpaceX. Can you tell us what Elon means when he says that SpaceX went to NASA and offered to bring Sunny and Butch back early? What were the details of that particular offer, and when was it made? Thanks.
Again, I think, we work for NASA, and we worked with NASA cooperatively to do whatever we think was the right thing. We were willing to support in any manner they thought was the right way to support. They came up with the option you heard described today by them, and we're supporting that option.
Thank you both. We have time for one more question, and that is Jim Siegel at Florida Media Now. Go ahead, Jim.
Hi, everybody, and thanks for taking my question. What are some of the most noteworthy investigations that are going up to the ISS on this particular mission? Thank you.
There are a number of things that the crew is going to do. I would say some of the most interesting work is actually in the human realm. We've got a series of human research experiments that are designed to help us further our knowledge for what we need to do for going beyond low Earth orbit. Some of these will be really, really critical for the extra long durations to Mars. We call them CIPHER studies. They involve looking at how our astronauts adapt to spaceflight over differing mission durations. This particular crew will participate in 14 of those studies, looking at different aspects of spaceflight on things like musculoskeletal health, brain behavior, cardiovascular system, vision, some of the things we know that are that change when the crew is exposed to microgravity over a long period of time. And so they're going to be a big help to us in furthering our understanding about what we need to do to protect crew health for those longer duration missions.
Thank you so much. That is all of our time. I'm sorry, we do have one additional, sorry about this. We have one additional from Josh Dinner at space.com. Go ahead, Josh. Josh, are you on?
Yeah, hi, can you hear me?
We have you. Go ahead.
Yeah, thank you. Has there been any recent pressing need to return Sonny and Butch from the station sooner that contributed to the Dragon spacecraft swap?
Let's see, I'll start from a station standpoint. They're doing great on board. I'm sure you followed along some of the really impactful things they did, like a couple of the spacewalks, Sonny setting a new record. So things are going well on board. They're doing great. There's no specific need from a station standpoint on board for their return. I will reiterate what Steve mentioned about our station mission schedule. You know, we have a limited number of docking ports on board Space Station, and so the logistics get pretty challenging as you're trying to slot in the different missions. With the Soyuz crew exchange in April, we like to keep to one set of crews handing over at one time. That way they can focus on handing over with their specific crewmates, Soyuz to Soyuz, for example. And so when I look at April being taken, part of April with that Soyuz handover, and then a critical SpaceX resupply mission that I'd like to fly in April, March makes sense in terms of an opening and the right time to go and do a crew exchange.
Thank you. Thank you, everyone. That's all the time we have this evening for questions. Coming up in just a couple of minutes, we have the CREW-10 Crew News Conference that is going to be on NASA Plus, and media can phone in questions to the crew. In the meantime, we will say good night. We will say go CREW-10. Thank you.
This will conclude today's conference. All parties may disconnect at this time.
Former astronaut Mike Massimino is in regular contact with Sonny.
I think the biggest obstacle here is the psychological mindset, missing the family, missing the friends, missing the things that we enjoy here on Earth.
Now, after 8 months, Sonny and Butch are set to